Number 10, we're given the polynomial in expanded form and we have to write it in factored form. So down here I have our factored method list. So going down our list, checking for a GCF should always be your first option. And they definitely have a number that divides both 18 and 27, and they do share some variables in common. I could already eliminate method 2 just by looking at the exponents. X to the 5th is not, there's nothing times itself that gets me x to the 5th. And looking at the numbers in front also, 18 is not a square and neither is 27. The last method fails completely also because it has to have 3 terms. So you can use the method that I showed you to find the GCF of 18 and 27 by making a chart and splitting each of the numbers. Finding a factor pair of 18, 9 times 2, and 9 splits as 3 and 3. And 27 splits as 9 and 3, and 9 splits as 3 and 3. After you make your factor trees, we look at the prime factors and compare what they have in common. I'm just going to put the commonality in this box. So looking at the list, they both share a 3, so cross it out and put it in the box. And then they also share another 3, cross it out and put it in the box. If there's multiple numbers, you multiply them together. That's all they share, so the GCF is 9. And then picking how many x's they share in common, you always pick the lowest exponent. Or if you wanted to, you could have put the x's also in the factor trees here. So the lowest exponent is a 2. So we know that the GCF is going to be 9x squared. Say you didn't want to do all this work too much and you just want to take a guess. So we do know it's 9, so say you pick something too low, like a 3. I'm going to show you how you can modify your work in order to get that 9. So I say 18 and 27. What divides 18 and 27? I think it's going to be a 3. So my best guess is a 3. And then I do know that the smallest exponent, x squared, is what they share in common. So say you accidentally pick 3. So figuring out what's left in the parentheses, you would ask yourself, 3x squared times what gets me back to 18x to the 5th? Well, 3 times 6 is 18. And then x squared times what gets me back to x to the 5th? Well, I know if you're multiplying, you add the exponents, so 2 plus 3 more gives me 5. And then I would say 3x times what? I forgot, sorry, bring down our minus sign. 3x squared times what gives me 27x squared? Well, 3 times 9 gives me 27. And since I already have x squared on the outside here, I don't need any more x's on the inside. So say you're like, alright, I'm done, this is my final factored form. What's our issue here? Right away I notice that 6 and 9 can still be divided by 3. So you're not finished. You did not pick the greatest common factor. Since I could divide both of these by 3, I'm actually going to pull out a 3, and I'm going to pull it out to the front, and I'm going to multiply it by what I already chose. I already chose a 3. So really on the outside now I have 3 times 3, which is 9, so 9x squared is on the outside. And then since I pulled out a 3, I need to divide the 6 and the 9 by 3. So 6 divided by 3 is 2, x to the 3rd minus 9 divided by 3, since I pulled out a 3, is 3. And this is completely factored. This is my final answer here, because 2 and 3 have nothing that I could pull out from them. We already knew that 9x squared was going to be the greatest common factor by showing the work, and this is completely factored.